This is Cubic Functions, How to Use Them, How to Draw Them, and How to Write Them by Heather Toomey. First, how to use them. You use cubic functions in predicting planetary motion, creating cryptography, doing 3D computing, calculating drag on vehicles, using thermodynamics, synthesizing planar dynamics, making computer transactions, and with hacking. So that means you'll use it if you want to be an astronomer, an astrophysicist, a novelist of fiction, if you want to create a new font or work with technology security, or even if you want to create video games. Pretty much anything where you're an engineer or doing something with the computer, then you'll need cubic functions. Also, if you get drunk and you throw your cat in a river, and the river is roughly the same size or shape as a cubic function, you could add time to it and plug it into a calculator and find out where on earth your cat is. So, yeah. The first thing that you need to know about cubic functions is that the formula is y equals ax minus h cubed plus k. So you might be wondering, what on earth do these letters mean? First of all, h and k are what you plug in as x and y for the vertex of the function. The a value is how many units the second point goes up from the vertex, which also means that if it's negative, then you go down from the vertex, and that is called a reflection. And as long as it's positive, the graph will always go from down to up, from left to right. If a is more than 1, then the graph is showing that there is a vertical stretch on your cubic function, and we call that a vertical stretch by as many as the number a is. So if y equals 3x cubed, since a equals 3, the graph has a vertical stretch of 3. If a is between 0 and 1, then the graph has a vertical compression, again by as many as the number a is. The parent function of a cubic function is y equals x cubed, and we will get to that in a moment. Before we can start graphing, we need to know how to graph. So with graphing, the first step is to graph the vertex using hk. So if h is 3 and k is 5, then your vertex is at 3, 5. Now remember, the equation is y equals ax minus h cubed plus k. Only take the h. If it has an x plus h, that means the h is actually negative. The negative is not part of the h. The second thing to do is to graph the 2 points surrounding the vertex using a. So if a goes up from the vertex, and if a equals, say, 4, then go up from the vertex 4 points and go to the right one. And that going to the right one is automatic. It just happens with everything, no matter what you're dealing with. The third step is to connect the points with a curving line. Now this line should point up and down, not left and right. If you do it correctly, it should have it pointing down and pointing up. These point left to right. So make sure you're graphing it correctly. You may or may not have noticed that on this chart there is this part. This part is kind of a cheat for graphing the points of your function. The first thing to graph is h and k, and from there automatically x goes up 1, so it's h plus 1, and from the vertex with y you add a. So if k is 3, and you have a vertical stretch by 4, then you're going to have a 7 right here, because 3 plus 4 equals 7. So we're going to use that in solving these next equations, which are examples. For this first example, we have y equals 2x minus 3 cubed plus 10. Using this graph that I showed you earlier, which I will show just for the sake of letting you see it all the time, shows us that with this equation, this 2x minus 3 cubed plus 10, we would plug in h and k like we did over here, and h is 3, k is 10, so 3 and 10. H plus 1, like we did over here, is 3 plus 1, which equals 4, so the next x value will be 4. The next y value will be the k plus a, since a is 2, is 10 plus 2, and that equals 12. So the next y value will be 12, and these will make up a point. One thing that needs to be mentioned is the ending behavior. Since this function has a positive a, going up on y gives you a higher x, and going down on y gives you a lower x. So as f of x goes to infinity, x also goes to infinity, and as f of x goes to negative infinity, x goes to negative infinity. And here's the graph for 2x minus 3 cubed plus 10. The next example is the parent function. How on earth do you graph the parent function? Well, the parent function, as we already know, is y equals x cubed. That can also be written as y equals 1x minus 0 cubed plus 0. So I've identified the points here or the values, sorry. A equals 1, as we can see in the pink. H equals 0, and k equals 0. So the vertex is at the origin, as shown here. Since a equals 1, it just goes up 1 from the vertex, and goes down 1 from the other side, since that's the opposite. So again, a is positive here, so end behavior goes up, and beginning behavior is going down, so down, up. The next example is a bit harder, but if you know the rules, it's not too hard. This one is y equals negative 4 over 3 times x minus 2 cubed. Now, we didn't go over exactly how to do what to do when a equals a fraction. We skimmed over it, but I didn't explain it very much. So with this, first we identify h and k. H is 2, because you don't use the negative, and k is 0. Simplified, it's just not there. So the vertex is 2, 0. And there we go, 2, 0. And once again, we've used this graph of this, kind of weird to say, so I'll just let you see it. So since h equaled 2, we put 2 there. K equaled 0, so we put 0 there. And then h plus 1, so 2 plus 1 is 3, so there's 3. And k plus a is 0 plus negative 4 over 3, which gives you just negative 4 over 3. So with this graph, I've drawn it so that it goes by threes so that we could do fractions more easily. See that this is 4 out of 3 and it goes down. So it's graphed in this way. Next are the steps to write an equation when given a graph. First, of course, as you can see, we identify the vertex and plug in hk for xy. And when you do this, remember again that h is already subtracted in the equation. So if it's negative, that means that h is positive. If you have a plus sign right here, that means h is actually negative. So just remember that when you're plugging in h and k for the vertex. And the second and final step before actually drawing is to count how many units the next point goes from the vertex and plug that in for a. So, for example, one of our examples goes up from the vertex by 1. So that means that a equals 1. And it's similar with this one. It goes up 2 from the vertex, so a equals 2. So that is how you write equations. And here are the credits. This information was taught to me originally by Miss Levitt. The video was inspired by Miss Child. The supplies I have, the paper and the Sharpies, were supplied courtesy of my dad. The music is by the Piano Guys. You should really check them out. They're on YouTube. They are fantastic. I love them. They mix pop and classic, so it hardly even sounds like classic. It just sounds like what you're hearing right now, minus my voice. And the presentation and props were made by me, Heather Toomey. So I hope this video helped and explained cubic functions for you, especially if you're a beginner. If you have any questions, follow some of the links below in the details of this video. So, thank you for watching. Hope this helped. Bye.